Hello, everyone. So, how was the day? It was full of excitement, lot of insights, different talks, and thank you so much for staying with us till end of the conference. This will be our one of the last talk, and we appreciate that everyone who made it till here, and we really enjoy that seeing you participating in the questions, using a lot of emojis, giving enthusiasm to everybody. Thanks a lot. And without ado, let me introduce our next speaker and talk. We will be having it from David Balenson, Associate Director at USC Information Sciences Institute. David is specialized in critical infrastructure security and leads NSF-funded projects like Pivot Spare. Today, he will be presenting Pivot, catalyzing the community around collection and sharing of automotive research datasets. This talk will cover the Pivot platform, which supports automotive heavy-duty datasets, sharing for research and vehicle cybersecurity and intelligent transportations. David also share key insights from a recent Pivot workshop. Let's give a warm welcome to David Blenson. David, to you.
Fantastic. Thank you very much, Jitendra, and welcome to everyone. I know it's been a long day, and I'm really happy that you're hanging on for this final talk on Pivot. As Jitendra said, I'm David Balenson. I'm the Community Outreach Director for the Pivot project. I'm also the Interim Director of the Networking and Cybersecurity Division at the University of Southern California Information Sciences Institute, or USC-ISI. It's an absolute honor to be part of the ASRG Secure Our Streets conference and to tell you about the Pivot project, which is working to catalyze the community around the collection and sharing of automotive research data sets. I want to start with the bottom line up front. The goal of the Pivot project is to develop a community-based platform that will catalyze production and consumption of both automotive and heavy-duty data sets and tools to support open research in vehicle system cybersecurity, intelligent transportation, and smart and connected communities. It's a collaborative effort. It involves the University of Memphis, Colorado State University, and USC-ISI, as well as an outside collaborator, Geotab, a global telematics company that some of you may be familiar with. The Pivot project is funded by the U.S. National Science Foundation, or NSF, under what they call the CISE Community Research Infrastructure, or CCRI program. And CISE is NSF's Directorate for Computer and Information Science and Engineering. And the key thing to understand about a CCRI grant is that it's about developing infrastructure to support research. It's not about performing the research itself. The grant started in October of 2022, so it's been going for about 2 years now. It'll run at least 3 years until September of 2025, though we do plan to extend it by 1 year until September of 2026. Here are some of the key members of the team, including, going left to right, Jeremy Daly and one of his students from Colorado State, Christos Papadopoulos and Spiros Thanasilis from Memphis, and me and my colleague Wes Hardiker from USC-ISI. This picture was taken during a recent team meeting that was held at the University of Memphis, and we're shown in front of the university mascot, the tiger. So I know I'm preaching to the choir here. As we all know, the attack surface of today's modern connected vehicles is huge and it's growing. It includes numerous internal components, lots of buses, and many internal and external interfaces, which are all targets of attack. The way I like to describe it, at least to a broader audience, and I realize this is oversimplifying, cars have become computers on wheels. Computers can be hacked, so cars can be hacked. This has led to lots of research on automotive cybersecurity. Here are some examples of recent NSF-funded academic research in the United States. There is, of course, lots of other research in both academia as well as in industry, not only in the United States, but other parts of the world, including Europe and Asia. In order to support this research into advancing the state of the art in automotive cybersecurity, researchers need access to high quality, real life vehicle network data sets. However, we have found that such data sets tend to be ad hoc, are hard to obtain, and have limited utility. And unfortunately, this prevents or slows the research community from growing the discipline. Therefore, we found there's a critical need for community infrastructure that can transform these smaller ad hoc efforts for vehicle data curation into a much larger scientific body of work done by a synergistic community. And that's where Pivot fits in. Here are some examples of current automotive research data sets. You may be familiar with some of these. The important thing to note here is that Pivot is not only interested in single vehicle data, as depicted in the smaller inner circle in the diagram on the left, but also other types of data depicted in the outer circles as you work your way from the inside out. So this includes vehicle fleet data. It includes vehicle to infrastructure data. It includes transportation data, and even goes as far as smart city and community data. And here are some examples of potential applications that can benefit from research that leverages these high quality data sets, including, of course, cybersecurity and safety, but also things like vehicle systems, transportation systems and fleet management, and again, the smart cities and communities. Also, since Pivot is funded by the US National Science Foundation, it necessarily supports their research programs, such as the Secure and Trustworthy Cyberspace, or SATSI program, their Cyber Physical Systems, or CPS program, and their Smart and Connected Communities, or SNCC program. So now, I advanced one too many. Okay, so now that I've talked about the motivation for Pivot, I want to switch gears and talk about the Pivot project and its 5 pillars: platform, data, tools, services, and community. Platform is the hardware and software upon which the system runs. Data is the collection, curation, and sharing of data and contextual information. Tools are the software used to process and visualize data. Services are the support provided to researchers for accessing, sharing, and securing data sets, including privacy services. And community refers to outreach and engagement to increase awareness, elicit feedback, and encourage sharing and use of data and tools. These are all in support of Pivot's goal of catalyzing the community and enabling research. And I'm going to briefly describe each of these 5 pillars on the following slides. The first pillar is the Pivot platform, which is an interactive hardware and software platform that provides user services, including access to data sets and tools. The platform supports a web server, a database, and a set of microservices. It's hosted at the University of Memphis and can be mirrored at partner institutions such as Colorado State University for resilience. Here we go. Looking more closely, the platform is composed of the Pivot website, which acts as a portal, a catalog based on Camunda, which is a service developed under another NSF-funded set of projects called ClassNet, and also a related project called Search. It also includes a repository or object store using MinIO, and then finally a shim, which sits between Camundo and MinIO to handle naming, authentication, and access control. Moving on to the second pillar, we have the Pivot datasets. We're actually working with 3 different types of datasets. 1, community datasets, which are contributed by the broader community. 2, data from Geotab's telematic devices as part of what we call the Pivot Spindle program, and also from Geotab's altitude analytics platform. And then 3, data from Pivot CAN loggers that we are developing for passenger cars and heavy trucks. And I'm going to briefly describe each of these 3 different types of data on the following slides. Pivot community data sets are produced by other researchers and or other laboratories in support of prior or ongoing research. So they're produced by folks like probably many of you. While such data sets may be available for use by others, they may not be widely known across the community. So Pivot basically acts as a portal to increase awareness of these data sets. Examples of such data sets include Oak Ridge National Laboratory's ROAD data set, the University of South Korea Hacking and Countermeasure Research Laboratory, or HCRL, data sets, the Bosch SynCan data set, and heavy truck data sets from Colorado State University. The Pivot Spindle program that I mentioned basically consists of a small fleet of Pivot researchers who have installed Geotab's Go9 telematics devices in their vehicles and who contribute their data and make it available to other researchers. In fact, I have one of these Go9 devices installed in both of the vehicles that I and my wife have here at home. The data is controlled by the Spindle administrators, and the goal is to provide data with as much detail as possible, though various levels of anonymization and user vetting are also possible. The fleet currently has about 10 vehicles across North America, and it even includes an electric vehicle and a heavy truck. The fleet is managed and information is accessed via Geotab's mygeotab.com portal. And here are some examples of the type of information that is collected and available through the portal. Some examples include things like trip maps, engine measurements, engine faults, fuel consumption, idling time, emissions reports, speed profiles, and much, much more. And you can imagine, given that Geotab provides fleet management services, these are exactly the kinds of information that, as a fleet manager, you would want to have access to. In addition to supporting Spindle, Geotab also provides researchers access to their altitude transportation analytics platform. So whereas Spindle provides data from individual vehicles and across a very small fleet of vehicles, Altitude provides contextualized transportation insights based on aggregated data collected from over 4 million connected vehicles that subscribe to Geotab's fleet services all across the globe. This data can be on specific roads across specific regions. As part of its support for Pivot, Geotab is providing researchers free access to their stop analytics and their traffic data from 2 different geographic regions, from Denver, Colorado, where Colorado State University is located, and also from Shelby County, Tennessee, where University of Memphis is located, both from the year 2022. If researchers are interested in getting broader access to the altitude analytics platform, then that is something that is potentially available based on particular needs and discussions with Geotab. And then finally, the third type of Pivot data is collected from our custom CAN Logger 4, which is being developed for both passenger cars and heavy trucks. It's designed to capture data across the depth and breadth of automotive network protocols, including CAN and Automotive Ethernet, along with the associated contextual information. It has an integral GPS, as well as vehicular, Bluetooth, and Wi-Fi interfaces. The overarching goal is to develop an open source, low-cost, all-in-one solution that can be distributed to volunteers who collect data and then return it to Pivot for sharing with other researchers. So the third Pivot pillar is tools. Jeremy Daly at Colorado State likes to point out that there are multiple layers of vehicular data as depicted in the pyramid shown here. At the bottom is the physical layer signaling, which is typically visualized as oscilloscope traces. Next up, there are data frames composed of, for example, CAN ID and data. Next are vehicle protocol data units, or PDUs, such as those defined by the J1939 transport standard and used by heavy trucks. Above that are the actual vehicle signals, including signal graphs like the ones that were depicted on the earlier slide I showed for the Pivot Spindle program. This data can be collected for a single vehicle using the Geotab Go9 or Pivot CanLogger 4, but also across fleets of vehicles, such as with the My Geotab portal and even Geotab's Altitude Analytics platform. And then finally, at the top, the tip of the pyramid, you have the data analysis that's supporting research. The key point here is that tools are needed to work across all of these layers. Examples of such tools include things like CanLog format converters and tools for signal decoding and data visualization. The fourth pivot pillar is services. These include the cataloging of and access to all the types of data sets and tools that I just described, as well as privacy support services and even support for researcher institutional review boards, or IRBs. And then the fifth and final pillar is pivot community outreach and engagement, which involves activities that seek to raise awareness, elicit input and requirements, and encourage contribution and use of data sets and tools across the broader research community. These activities include maintaining content on the Pivot website, writing papers and articles, conducting webinars, engaging in social media, participating in conferences and workshops like the ASRG SOS conference, organizing cyber challenge events such as Cyber Auto and Cyber Truck, and holding Pivot community workshops. Here are a couple of screenshots from the Pivot website showing the data sets and community web pages. On the left, what you see is the beginning of the current listing of community data sets. And on the right, what you see is information about the various Pivot workshops that we have run as part of the Pivot project. Speaking of the workshops, we have so far held 3 community workshops. The overall goal of the workshops is to bring together the community around development and sharing of robust automotive and heavy-duty data sets to support open research in areas with strong societal impact. They're held roughly once a year, and they're held virtually to maximize participation around the world. The first workshop, held in November of 2021, focused on data sets and applications. The November 2022 workshop focused on CAN loggers and data privacy. And the recent April 2024 workshop focused on the Pivot project and beyond CAN. The materials from all of these workshops, including slides and recordings, are available via the links that are shown, or you can just go to the community page on the Pivot website, which I showed on the previous slide. So I'd like to share some highlights from the recent Pivot workshop. Here's the full agenda. I don't expect you to read it, but I did want to show you that it was a full 2-day agenda. It included plenary talks from the Pivot team, but also members of the community. It included a series of lightning talks from researchers all around the country and the world. And then also it engaged people in a couple of breakout sessions where we had focused discussions around important topics. Here's a high-level overview of the workshop, which hopefully you can read. Day 1 featured Pivot updates, lightning talks on automotive research, and a breakout session on the Pivot project. Day 2 featured a really cool keynote talk from Mike Westra at Ford, community updates from ORNL, HCRL, and others, and lightning talks on automotive data sets, as well as a breakout session on Beyond CAN. And then finally, a wrap-up session on how Pivot can best serve the community. I'm going to briefly summarize the keynote talk, the breakout sessions, and the wrap-up session. I'd love to talk about all the other sessions as well, but unfortunately we don't have enough time, but you can find information about all of these on the Pivot website. So one of the highlights of the second day of the workshop was the keynote by Mike Westra from Ford, who talked about automotive cyber beyond CAN. This was basically a reprise of a keynote talk he gave at the Vehicle Sec Symposium, co-located with NDSS, in February of 2023. For the workshop version, he covered 3 primary topics, including CAN and Ethernet, adaptive AutoSAR, and EV, EVSE, and charging infrastructure, and basically presented his perspective on the research challenges and needs in each of these areas. Mike's remarks were very insightful, and I encourage you to take a look at his slides, which are available through the Pivot website. The first of the 2 breakout sessions focused on eliciting feedback on key elements of the Pivot project through a series of prompt questions, which you see listed here. When asked about the Spindle program, participants noted the safety incentives of having a telematics device such as the Go9 in their vehicle, but they also raised concerns in the need for data anonymity, which frankly is something we hear about all the time and certainly understand. It sort of goes hand in hand with collecting all this data. You also have to consider privacy concerns. When asked about the Altitude program, participants said they would love to be able to enrich such analytics about all the different vehicle behavior that I mentioned earlier with driver behavior data as well. They also wondered if the data that's available through this analytics platform could also be used to augment driving simulators. Regarding CanLogger 4, participants liked the idea of enabling applications at the edge, including supporting researcher-contributed programs and services such as data anonymization or filtering. They also liked the idea of augmenting the logger with an adjacent Raspberry Pi for heavier workloads, and they also hoped the logger would support full data rates from all of the different channels. Finally, when asked about CAN-FD and Automotive Ethernet, participants noted that while Automotive Ethernet is becoming more prominent, hybrid systems with older technologies such as CAN, CAN-FD, and LIN will probably persist for some time. They raised the need to architect hybrid systems to accommodate different levels of criticality, suggested that one could potentially diagnose problems in one network by monitoring it from another, and noticed there could be challenges translating signals that are moving among the various networks. The second breakout session focused on beyond CAN. So a lot of automotive work, including data collection and sharing, has focused on CAN data. So this session explored what data is needed other than CAN in order to support research. Participants, of course, identified Automotive Ethernet as a critical need. They also discussed the idea of using test beds to generate research data, as well as the need for data related to security control profiles and the accompanying risk assessments, and data related to cooperative perception and measurements. One of the challenges with collected data from vehicles with multiple buses using different protocols is correlating those data sets within a single vehicle, including time synchronization across all of them. While there wasn't much discussion on how exactly to address this, participants did note that it would be nice to collect data not only across all these different networks, but on user behavior as well, which of course just adds additional synchronization challenges. Participants expressed the need for tools to support data visualization, custom protocols, including support for hardware security modules and trusted execution environments, data from sensors such as cameras and LiDARs, and also support for Covasa's vehicle signal specification. They also pointed out that it was important for the tools to be user-friendly and easy to use, and other topics that were discussed included mixed criticality networks, network separation, microkernels, and hardware support. So we wrapped up the workshop by asking how Pivot can best serve the community. And each participant was asked to share something they liked about the workshop, a suggestion for improvement or an idea for a future workshop, and how Pivot can support their research. Participants especially liked the diverse participation, which included industry and government representatives, as well as researchers, faculty, and students. They also liked the lightning talks, which allowed a lot of people to present the work that they were doing, the data sets that they were using. They liked the breakout sessions. And in the case of the students, many of them were just learning about all these topics and data needs for the first time. So it was very educational for them. Suggestions for future workshops included brainstorming sessions on collaborative research proposals, more breakout discussions, and even demonstrations of various tools. Participants also asked for in-person workshops with hands-on activities, as well as ongoing activities such as webinars. So a mix of both in-person and virtual meetings. Finally, participants identified a number of ways Pivot could support their research, including providing data with attack data for forensic analysis, data for specific focused research needs, and data for automotive Ethernet research. Areas where they could benefit from Pivot included working on EV challenges, such as range prediction, tools for working with automotive software bill of materials, and moving research from lab to the real world. Several participants said they will cite Pivot in future proposals, sign up for the Spindle program, and try to align their research efforts and form collaborative teams with other members of the community, which is exactly what it is that we are striving to do with Pivot. So it was wonderful to hear people realizing, understanding, and expressing their interest and desire and willingness to follow through on this. So now that I talked about the April 2024 workshop, I want to switch back to Pivot and wrap up. Before I do that, I want to note that Pivot supports a number of educational activities. Memphis, Colorado State, and USC students are all directly supporting Pivot. The project provides artifacts and resources that can be used not just by the Pivot team, but also others to educate the next generation of automotive cyber engineers. And of course, we emphasize diversity through efforts targeting minority institutions and underrepresented groups, and we engage and educate students through the cyber challenges. Speaking of the cyber challenges, some of you may already be familiar with these, but if not, I highly recommend you take a look at them. There's the Cyber Auto Challenge, the Cyber Truck Challenge, the Cyber Tractor Challenge, and Cyber Boat Challenge. Cyber Auto has been running since 2012, so well over a decade now. Cyber Truck since 2017, and Cyber Tractor and Cyber Boat are relatively new. In fact, there's an upcoming Cyber Boat Challenge this December. So if you think that might be of interest to you or someone you know, you should direct them to the links listed here, which are, of course, available through the Pivot website. These events all help develop the next generation workforce and provide awareness, excitement, professional involvement, and practicum-based training for students. So they're really a very effective way of bringing together people from academia and industry, along with professionals and faculty and students in order to be able to develop these students. So I want to, again, introduce the core Pivot team. Christos Papadopoulos, Spiros Thanassilis from Memphis, Jeremy Daly from Colorado State, myself and Wes Hardiker from USC-ISI, and Stephen Christensen and Ted Guild from our industry collaborator, Geotab. Please feel free to reach out to any of us with any questions or interest you may have regarding Pivot. I also want to acknowledge our advisory board, which is composed of leaders and visionaries from academia and industry across the researcher, automotive, data provider, and data analytics communities. So folks such as Andre Weimersketch from Lear, Anita Nikolic from University of Illinois, Urbana-Champaign, Gader Bloom, University of Colorado, Colorado Springs, Dr. Hoikang or Hugo Kim from HCRL at Korea University, Mike Branch from Geotab, and Mike Westra from Ford Motor Company. Together, all of these board members provide invaluable advice and guidance to help drive the Pivot project. So in summary, we see, and hopefully you see as well, many benefits to Pivot. It helps coordinate existing isolated efforts. It facilitates exchange of knowledge and resources, nurtures ongoing conversations, stimulates pre-competitive research collaboration, and provides resources to educate students and others. It also engages industry, including OEMs, suppliers, and other important partners, and engages relevant standards bodies and applicable government organizations. The impact of these efforts is to create a robust ecosystem that works to develop and share community resources, including automotive and heavy truck research data sets and tools, which in turn enable researchers and folks like yourselves to address important problems, define high-quality research initiatives, and ultimately develop new innovative technologies to secure modern connected vehicles. So I want to close by issuing a call to action. We clearly see strong synergy between the Pivot and ASRG communities around automotive cybersecurity research, education, workforce development, and data sharing. We look forward to working with ASRG, its members, and others in the community, including all of you. Please reach out to us. Tell us your research needs and requirements. If you have data sets and tools, share those with us so we can share them with the rest of the community. If you need data sets and tools or other resources, leverage the ones that are available in Pivot. And then look for and participate in our workshops and other events. You can always connect with us via email, our website, and social media. So thank you again for sticking through to the bitter end. I really appreciate the fact that you're all here, and I'm happy to answer any questions that you may have.
Thank you, David. It was very insightful and a lot of information we received and a lot of questions as well. So I will
Good.
take it one by one, as many as possible. And let me start with the first one. Have a consents been obtained CV2X, DSRC, FGAA, WLAN, or MASH network going forward?
Yeah, so honestly, I'm familiar with many, but not all of these protocols. And in terms of consensus, I'm not sure. And I'm probably not the best person to answer this question. We are interested in making data from all of these different types of protocols available to the community if that's something that would be of interest to you. But in terms of the standards bodies and industry and others working around consensus on the nature of these protocols and their adoption, that's really outside the scope of Pivot and also just outside the scope of my knowledge. But certainly, if there's interest in these type data sets from these types of protocols, that is exactly something that we want to hear about from the community.
Thank you, David. I'll take it to the next. Do any of the post-quantum techniques been successful to avoid vulnerabilities?
So again, this is a little bit outside of the scope of what we're trying to do with Pivot. I am vaguely familiar with some of the post-quantum technologies. There have been presentations on efforts such as NIST to develop post-quantum crypto at various conferences like SCAR. And also I think they presented at the ISAC Cybersecurity Summit. And NIST actually has been running competitions for the post-quantum crypto algorithms. And just recently, I think late August, they announced formal FIPS. If I recall off the top of my head, FIPS 202, 203, and 204, where they have standardized several of the candidates as actual FIPS, Federal Information Processing Standards. And they're still working on some alternatives to those as well. And I would encourage you to reach out and look at other resources to understand what NIST and other folks in the community are doing to adopt post-quantum crypto to protect against potential vulnerabilities, as well as looking at crypto agility, which is a way of transitioning from current algorithms, asymmetric algorithms such as RSA and ECDSA to these new post-quantum crypto standards.
Thank you, David. Let's move to next question, which brings is the CAN logger 4 able to probe for the CAN bus data, or does it only listen passively to it?
Yeah, this is a great question, and it is one that's within the scope of Pivot. However, I have to admit, I'm not 100% sure. I think it can actively probe it, but we'll have to check with Jeremy Daly, who may or may not be on. What I would encourage, Victor, for you to do, if you don't mind, I and one of my other colleagues, Christo Papadopoulos, if not also Jeremy Daly, will be on in one of the lounges after the session, and we could talk to you a little bit further about this.
Thank you, David. Let's move to our next question about CAN bus data. How heterogeneous is it among the different vehicle models? A challenge here is that they might have a lot of variations. Some of them might require access to the vehicle to clean them and understand what is available per model.
Yeah, this is absolutely right. CAN data does vary across different automotive manufacturers, across different makes and models, and that makes it a real challenge. You can collect data from certain makes and models, and it may not necessarily help you with others. And so this is one of the reasons for having the Spindle program and for having the CanLogger 4 program. So the basic idea here, and I didn't actually use these words, I could have and probably should have, is in effect, these programs are making devices available to researchers around the country, around the world. So we're sort of crowdsourcing the collection of data. And so by recruiting different volunteers who have access to different vehicles, we potentially broaden the set of vehicles from which we're able to collect data and make that available. And then, as I mentioned, this only gets more challenging now that you're starting to have this transition away from CAN only to having automotive Ethernet and these hybrid, vehicles with these hybrid networks that are then, you could have as many as 10 to 12 different networks, within a vehicle connected through a gateway. You might have an OBD2 port that connects to the gateway and limits what you can see to just one network at a time if you have the proper access codes, or just limits you to diagnostics data. And so we're seeing greater and greater challenges over time as the nature of the internal networks changes to being able to collect and provide data needed to support research. And then further, as you said, in some cases, depending on what you're trying to do, you may need direct access to the vehicles. And so, again, by crowdsourcing the devices and letting researchers install them in their own vehicles, they can then expand the set of vehicles and get direct access to them. And then there's also various efforts, including testbed efforts. I know that Black Harbor has something called VSEC, their Vehicle Security Engineering Cloud, if I'm not mistaken, which is a way to also provide researchers access to vehicles through a standard testbed interface or platform, if you will. So this is, in effect, one of the biggest challenges that we face right now, and that Pivot is hoping to bring the community together, rally them, and try to crowdsource and overcome this.
Thank you. Our next question is in AutoSAR, PDU router aggregates most buses before going to applications through communication manager and runtime environment. So this
Yeah.
PDU router does make sense for multiplexing all vehicle networks.
Yeah, this is outside of the scope of what Pivot's interested in terms of collecting data. So I'm honestly not familiar enough with AutoSAR and these particular aspects to be able to answer definitively about this. But again, if this is an area of interest, if it's an area of concern, an area of research, and it would be useful to have data that helps support work around this, that's something that we would want to know about, and then work with folks in the community to figure out how we can collect data to support research into and answering questions like this.
Thank you, David. One last question, we will take it.
Okay.
I think I missed it. What are the best practices that you use to handle private data to release public data sets? For example, how should we handle GPS?
Yeah, thanks, Victor. So this always comes up, never fails, and we're well aware that this is an important challenge. It's sort of the flip side of the data collection coin, and you didn't miss it. I didn't go into any great detail. I just mentioned data anonymization and filtering and things like that. But this is an area of considerable concern. Um, Ideally, we would like volunteers who install pivot spindle or CAN logger devices into their vehicles and make that data available, to make it available as openly, as freely as possible. But we understand there can be sensitivities. So, for example, with the pivot spindle program, Geotab actually within their portal has the ability for individuals to create effectively what are geofences, which limit where data is collected. So, for example, you could limit data collected around a home or a place of business. You can also adjust the granularity of the data that's being collected. The altitude analytics platform that I mentioned, it is all aggregated data. So none of the fleet data that they are collecting and make available is specific data about any one particular vehicle. It's aggregated data, it's analytics across all of these different vehicles that they manage as part of their fleet management services. And then one of the tools that we recognize is important and needed, and that we are going to be working on, especially during the third and likely fourth extension year of the project, is around data anonymization tools and other things that can be used to anonymize, filter, aggregate, whatever makes the most sense, depending on the particular set of data and what it reflects and what needs to be protected. And then the final thing I'll mention is this is also an area of active research. It's not always clear how best to do this. And so to the extent that Pivot anticipates supporting not just current research, but future research, I would encourage people to think about proposing new future research efforts, such as, for example, there's a lot of work on privacy enhancing technologies or PETs. And so one could think about how could these new advanced technologies be applied to automotive data. And that would align very nicely, not only with the kinds of challenges we're trying to address within Pivot, but research challenges that others, including researchers within ASRG, are trying to wrestle with. So thank you again, Victor. Very, very good question.
Thank you, David. And thank you so much for answering all these questions. And thank you, audience, for asking these questions, wonderful questions. And I know the Pivot project is not so easy to summarize in one session. There could be many, many more sessions are required. We appreciate David's effort to summarize and bring this project into the one session and provide a value to the audience. Thank you so much, David. We really appreciate your time and effort. And thank you, audience, sticking with us till the end of all the sessions. So hats off to you. Thank you for making this conference successful. Have a great time. Enjoy. Bye-bye.
Thank you, Jitendra. Thank you all. Reach out, meet us in the lounge.